The stream is going. Yeah, so today we're going to be talking pretty much exclusively about resources. So resources are arguably the most important concept in Cadence, and they call it they call Cadence like a resource-oriented programming language. So yeah, resources is pretty important. And for those of you that are doing NFT projects or planning on doing some type of I would say hackathon project where you're requiring some sort of asset, this is going to be very important for you to explain how to represent these different assets in Cadence. So what I have here is oh yeah, just load it up. Hopefully you can see that. So what I have loaded up here is a empty contract called profiles. And when we talked about structs, we had something like, a public struct, let's say a profile. And inside that profile, we had like a name string, we had like a favorite number, like an int. And then we initialize these things, right? So let's say we made name a string and fave number integer. And then we simply set self.name equal to name and self.fave number equal to fave number. And what we did by doing this was we basically defined our own type, right? This is a type that is essentially a profiles.profile. And anyone in any contract ever could call into this contract and create this struct. So if I was to deploy this contract and go into a transaction, I could create this thing. I could say, you know what? Let's go in the execute phase, and I could say let a profile equal a profiles.profile and pass in a name, which is like Jacob, and a fave number like 13. And then boom, I have a profile here, and I could do whatever I want with this, right? I could make my own contract that takes in a profile and logs it to the name. I could make my own contract that stores a list of profiles and just store this profile as one of them. I could do a number of things, right? But this starts to get a little strange when you start talking about how you want to represent like assets like NFTs or tokens or whatnot, because you want the creation of those things to be very secure and very limited. So, what a lot of people might do is they might think, oh, well, a good way to represent an NFT is to just name this an NFT and give this, like an ID. Maybe we could give this a ID, and then we could just mint NFTs and store these NFTs in maybe a bigger struct that just stores an array of NFT structs. But again, you're going to run into the problem of, how do we handle the minting of that? Because right now, anyone could mint an NFT in a transaction. Um, how do we properly store these things, right? Because you can overwrite structs, you can easily copy them. And that's not, attributes that we want associated with more complicated assets. So the long-winded, point here is that we need to use something called resources. Um, and resources are actually very similar to structs. You literally just change the name struct to resource, and you have a resource now. But the way that you handle resources is very, very, very different. Um, the first one, the first difference being that resources have a hidden field that you can imagine. It's a hidden field called UUID. That's a UN64. So it's actually here. You just can't see it. In fact, if I try to redefine it, you'll see it says cannot declare field here, UUID, because it actually already exists. So just pretend that it is here. And we can say, we can set our manual ID, self.id equal to self.uuid, which is pretty cool. So every resource on Flow has what's called a unique identifier. So whenever a resource gets created across any contract anywhere on the blockchain, it will always have a unique identifier, which is helpful for distinguishing between different resources. And in addition, if we redeploy this contract, you'll notice that we can no longer actually create the type in a transaction. And so, in fact, what's really going on here is when you define a resource, you can only ever create a resource inside the contract unless it's specifically defined that we can make it outside the contract. So let's make a function called I don't know, create NFT, and inside this we're going to pass in a name and a favorite number. int. And what's going to happen is let's create a NFT. So let NFT, and let's try to use the equals. We're going to come back to why you can't do this, but let's try to use equals. Um, NFT, like, let's try and treat this as if it's a struct, where we pass in the name and a fave number. So multiple problems here. Number one, whenever you want to create a resource, you actually have to add the create keyword. So this is problem number one. You have to make sure you add this create keyword. And this create keyword can only ever be used inside the contract. So you can't create a resource outside the contract. And number two is you can't use equals. You have to use what's called the move operator. So essentially, we're creating an NFT and moving it into this variable. And then what we're going to do is just destroy the NFT by moving it into a destroy call. Or actually, I think with destroy, you actually don't even need the move operator, but imagine as if it's moving again. Um, but let me try and get this point across even further. Let's say that you have another variable called NFT2, and you want to move this NFT into this variable. Now the resource exists here because we created it, we moved it into here, and now we're taking it from here and moving it into this variable, and so it no longer exists inside NFT. This is very different from structs because if we had a struct, we would have something like, equals, and then we could do another equals, and both NFT and NFT2 would have copies of that, of that object. However, with resources, you can only ever move them around and they only exist one time. So you have to explicitly move them to different areas, which is pretty awesome. And this is very aligned with, some of the like, traits that we want of NFTs, right? We only want them to exist once. We don't want them to be copyable. We don't want them to be easily lost. And we want to be able to, securely control the minting and creation of them and the transferring of them and all that kind of stuff. So, yeah. So what we can do now just to get rid of the errors is you'll notice that it says loss of resource. This is a very common error in Cadence when people leave their resources hanging. So what happens in Cadence is it basically tells you um, you need to do something with resources. You can't just leave them hanging. You have to either destroy them, store them somewhere, or return them somewhere. You can't just leave them. So what I'm going to do is I'm simply just going to destroy it. So after this line, this resource will no longer exist. And maybe in the middle here, we can just log NFT.name just for it. So let's go ahead and redeploy this contract. And let's call into the thing here. So let's say profiles dot create NFT, and let's pass in a name. Let's make these transaction arguments and a fave number. Pass it in. Let's pass in Raven and 14. We send it. You'll see it's going to log Raven, and that's actually coming from the contract when we log it right here. Any questions so far about maybe the differences between structs and resources? All right, it seems like we are all good. Cricket, yeah, sometimes crickets is a good thing. Guess people are following along. Okay, cool. Um, so let's give another example of moving it around. Let's say that instead of destroying it, we actually want to return it. One thing to note also is that resources are written in a interesting. Their type is written in an interesting way. You would think it's just NFT, that's their type, but actually resources, they have this at symbol in front of it. So when you define a resource type, you actually have to denote it with this symbol in front. So this means it's a resource. And instead of destroying it, we can return NFT back to the caller. And you'll notice we can't just put return NFT. We actually have to explicitly move it to the return value, and that gets returned here. So let's redeploy this. Confirm. And if we go to our transaction, we can actually say let NFT. Um, we move the NFT out, and then we can log NFT.name and then destroy NFT out here. So you'll notice that before I said we can only ever create NFTs in the contract. Although that is true, here we actually are exposing a function that the public can call the NFT out of the contract into a transaction. So that is allowed. And we can do this again. We can pass in Powell 2 and send it. We get Powell, and that's getting logged right here. All right, so let's go ahead and make a array here called NFTs. Let's just say files, and let's make a UN64 to an NFT mapping. So what we want to do is we want to map the ID of an NFT, to the NFT resource itself. All right. So let's do that. So we want to do is we want to we want to create an NFT and then store it here in the profiles dictionary where we're going to map the NFT's ID to the actual NFT itself. One thing we see here, it says missing resource annotation at. So with any type that includes a resource, again, it's a little confusing. You would think you have to put like an at here because you're telling it that it's a type, but actually when you're dealing with resources at all, you always put the at in front of the whole type. So the at actually goes here. And then we have to initialize profiles. So let's make it an init statement that says self.profiles. We move in an empty dictionary. So we have to actually use the move operator, even though we're not technically moving resources around. We are, setting the value of a resource type. So therefore, we can't use equals. We have to use the move operator. Okay. So let's start storing profiles here. So we already have a function called create prof NFT. Although I guess maybe we want to change this to a profile just to make this make more sense. Um, let's make this a profile. We're no longer going to return anything, and we're going to create the profile, and then we're going to store the profile in this array. So how do we do that in profile as well? We can say self.profiles at profile.id move in profile. So what we're trying to say is at profiles.id, right? This is the same thing as when we were trying to use structs or addresses and strings. Similar thing, except we're just using the move operator. Saying at profile.id, which is at UN64, try and move in the profile. Now, we're going to get an error here. It says cannot assign to resource type target. Consider force assigning with this or swapping. I never really use swapping, but the way to fix this is to actually put the force move operator after the arrow. So this is my favorite piece of syntax right here. I love this for some reason. Um, but it definitely is a little confusing. Now, the reason we have to put that there is because with resources, remember that one of the concepts of Cadence one of the concepts of Cadence is that resources cannot overwrite each other. And so Cadence is being very strict about this. It's saying, you know what? If there's a possibility, like we know, for example, that profile.id is never going to be the same as any other profile because we're using a UUID. So it's literally impossible for this to be the case. However, Cadence doesn't know this really. And let's say there's a different contract where it's the same use case, but we're setting all the IDs equal to 1, then this will be a massive problem, right? Because we could potentially be moving a profile into a spot that already has a resource. And again, because Cadence does not want to allow overwriting of resources, it's saying, you know what? Let's make a force move little sign here so that if something does exist at this spot, just panic and don't do any of this and just abort the transaction. However, if nothing lives here, then move the resource in. So this is saying if something doesn't already exist there, then move it in. Otherwise, abort the transaction and do nothing. And by the way, when I say abort the transaction, I mean that anything that happened during the transaction will just get reset. So if something happened before this and then it aborts, the thing that happened before won't have happened. All right, sweet. And then let's redeploy this and let's try and see. We can go into a transaction and let's just say profiles dot create and I thought they called this a profile. Employee, go to a transaction dot create profile. We pass a name, favorite number, and then let's just log done. So the name, let's say is D. Send it, and we get done. And so now BZ's profile should live inside the profiles dictionary here. All right, any questions on that? Monster Smasher, I like your profile picture. I think isn't that Invincible? That the name? Spider-Man. Yeah, that was an amazing show. All right, cool. So now we're gonna get into how to actually deal with resources and move them around and read their information. So one of the issues that we're gonna find that we're going to face now is like coughing in the background. But one of the issues that we're gonna face now is we want to try and read this profile's data. So how do we do that? Well, I actually want to take any guesses here. Let's see if someone in the chat can get this down. But what is going to be some issues with trying to read this profile's data? If profiles can only exist in one spot at a time, what's going to be an issue with trying to read into that profile? Or like return this profile back like to a script or something? Any guesses in chat? Let's say during a script, we want to try and read this profile. What are we going to have to do in order to actually get this profile into a script? Yeah, Raymond, you're definitely on the right track. You have the general idea down. Let's see if Darth Nubius can get it. Yeah, you're basically right, Raymond. Darth Nubius also can get it. Yeah, thumbs up. Yeah, so yes, so you're totally right. So the issue with resources is that when we go inside of a script, we're going to have to like return this profile, or we're gonna have to take the profile out of this profiles dictionary. Then we're gonna have to read its information and then put it back in the dictionary, and that's you know super annoying. To have to move it around a lot. So the answer then is something called references. So we want to make a reference to this resource in storage and then move the reference around, and we can read the reference in the script, but we leave the actual resource where it lives. So you can make a function called getProfile that takes in a profile ID and returns a reference, which is denoted by this symbol, to a profile. So this symbol represents an actual resource asset, like the object being moved around, whereas this represents a reference to it. So what we can do is say return a reference. This syntax gets a little bit complicated, but stick with me. Return a reference to self.profiles at the profile ID. Okay, and then so this is a reference that you would think this is all you need, but we need to actually cast it. So we need to tell Cadence what type we're expecting. So we say as a reference to a profile. So then we're going to get this error. It's going to say mismatch types expected profiles.profile got a optional type, a profiles.profile. So there's a couple ways to fix this. Number one is to simply just return. Oh, Oh, wait, I forgot about Ngayo. That's so funny. Wait, what was the whole joke about Ngayo with this? I can't remember. I remember there was something there, but I can't quite remember. So the solution is one of two things. We can either just return the optional and just cast it to an optional type. That's fine. Or we could actually just return the full reference and simply wrap this entire expression and then force unwrap it. Um, I actually prefer to return the optional because again, I think it gives your client more options on, or at least the caller more options on what to do. You can handle the case where it's nil instead of just the script. Um, and the reason it's an optional is because remember you're reading into a dictionary. So anytime you're reading into a dictionary, you're getting an optional type. Oh yeah, yeah, that's what it was. And I hated this so much. We had for anyone listening, we had like a student named Ngayo like 4 months ago, and every time we used this, he like was raging in chat. It was so funny. Um, but yeah, I miss that guy. Thanks for bringing that back up. That's hysterical. Okay, yeah, so let's redeploy this, and let's run a transaction again to put let's say Darth Nubius in here. Actually, let's put Ngayo in here. Represent his spirit. Favorite number was probably 100. So let's send it, and let's go into a script, and let's try and read this. So let's say let profile reference equals, and we have to import profiles from account one. Oh, and also note that with references we use equals. So references are not like resources where we have to move them around, right? You can copy references, you can store, you can whatever you want. You can overwrite them. It's profiles are not like the resource itself. So that profile ref equals profiles dot get profile. And we need to pass in a profile ID. And let's say we want to return a string that is the profile name. So we can return profile ref dot name. Oh, and remember, it's giving us an optional type. So this is the type it's giving us, profiles dot profile optional. So what we can do is we can just unwrap this thing right here and then do dot name. And we're going to unwrap the optional, then get dot name right here. So we can type in, oh, I wonder what the profile ID is actually. Oh, I have no idea. The reason I have no idea is because the profile ID is actually the UUID, and this is a random number, right? So we actually have to make another function here called get profile IDs. And this returns an array of all the IDs of the profiles that we're storing. So returns self.profiles.keys. So what this will do is this will go to the dictionary and return all the keys. It'll return an array of all the keys, which is an array of UN6. That's what this is. So let's redeploy this contract again. Let's type in ngayo. Let's type in 100, send it. And if we go to the script here, we can add another script, call it get all IDs. And we can here return an array of UN. We're not going to pass in the argument, and we're simply just going to say return profiles get profile IDs. Execute, and we see we get 38. Boom, that's one of the IDs in there. 38. So we can go to the script. Let's call this get file. And let's try it. So if we type in 38 here, we execute and we get ngayo. Perfect. Now, one thing that might be helpful, because look, if we type in like 40, right, it's gonna just abort because it's gonna say unexpectedly found nil, and that's happening right here. So one thing we actually can do is we can use I think it's called like optional chaining or something, where you actually put a question mark here saying, you know what, Cadence, it's okay if this thing is nil, just don't access the name, and then return a string optional instead. And that way, when we type in 40, we just get nil instead of actually getting an error. So sometimes that's better as well, where you can leave it as an optional and just tell Cadence it's fine, and just say, you know what, if it is an optional, just return null and don't access the name. But if it is not nil, then access the name. Fine. So that's another helpful thing to do. And again, this is all in the name of giving your client or caller more options on what to Pieces. All right, everyone doing good? I'm gonna pause on this one for a couple minutes, and then we're gonna get into interfaces, which will be the last concept of today's workshop. All right, seems like we're all good. So let's get into interfaces then. So I would say that the next part of this workshop, first of all, I think we should end a little bit early today, so maybe like at 11:45 Eastern. So it should only be like 51 minutes or so, just in case anyone's curious about managing time. But yeah, so interfaces are a weird thing to teach right now because the truth is that they're not actually going to become useful until next workshop when we start talking about account storage. However, the point of this next segment is just to teach you what they are, and then the next workshop I'm going to teach you like why we use them. So if you're asking yourself why, don't worry about that until next time. Just try and understand like actually what they're doing like functionally, and that's all you really need to know until next time. So resources are two things, or sorry, interfaces are two things. Either they're like ways to restrict references to only be able to access or call certain functions, and the second thing that they are is requirements for resources and structs to implement or whatever is implementing them. Hold on, I'm getting a phone call. Let me just hang this up. Sometimes when the phone rings in my house, it rings for like 10 minutes straight unless I hang it up. Okay, so let's make a public resource base, and we're going to call this iProfile. Um, Weirdly enough, if you've coded in like Solidity, you know that that interfaces are usually denoted with like I and then the name that they're going to be implemented on. But in Cadence, the for some reason the standard is to write profile public, or like to write profile something like profile admin or profile public or something like that. I actually always prefer just to write iProfile like they do in Solidity because it's just so much shorter. Um, but yeah, so let's actually go in here and say, you know what, we want this interface to have, let's say, an ID, or, and we also wanted to have a pet name, pet name string. Now, in interfaces, you don't actually have to implement or you actually can't um, initialize these data because an interface isn't really anything. It's just something that sits on top of whatever else, like whatever it's supposed to be implemented on. Tell it that it has to have those certain fields. So in this case, what happens is we take our profile and we say, okay, this is going to abide by iProfile, or it's going to be, whatever is in here has to be in here. So profile, in this case, gets an error. It does not conform to the resource interface because you can see that although we have the ID, right, the ID, we don't have the pet name. So we actually have to bring the pet name into here and say, okay, um, self.petName equals, and we can pass in a pet name, um, boom. And now all is good. Oh, wait. Okay, yeah, now we're gonna get, let's actually, for now, no, let's keep it here. Pass in a pet. Actually, you know what? That's gonna get annoying. Not use pet name, but let's just keep it with name. But you get the example. So it has to have the ID and the name, right? Which is pretty cool. So yeah, so that's all that happens when that's the first use of it, right? It's saying, okay, profile must have these certain fields. And also functions, by the way. If we say, let's say I have a public function inside a resource, which we haven't actually talked about this, but you can also have functions inside your resources. And in fact, most of the time you do. Public function, let's just say log name, or I don't know, get name, and we just like return string, and we say, okay, return self that name. We could also make that a requirement in the resource. So we could say, you know what, you have to have a get name function, and if we don't, you'll see we also get errors here. So we have to have a get name function that does something. Okay, so boom, that's right there. So we can redeploy. Then what we can do is we can make a function right now that says, you know what if we want to return the profile reference to the caller in a transaction or script, but we don't want them to be able to read the favorite number. We only want them to be able to read the ID and the name. Luckily, because that's what's in the iProfile, we can actually return a reference that is restricted to this type, the iProfile type, such that the user can only read the ID and the name and they can't read the favorite number. So if we go to here, let's go to this function. Let's make another function called getProfile restricted. We can pass in a profile ID and return a profile that is restricted to iProfile. So that is how you denote a resource type that is restricted to a resource interface. You put these little curly brackets here, and then put this type in here. And we can say, okay, we want to restrict it to an iProfile. Boom. And what we could also do is then we could take away this function so that users are never able to read the favorite number of the profiles that are stored in here. So we can redeploy this. And let's go back to our script here, or let's make a transaction that makes a new profile. Say Darth Bias 10, send it, and go to get all IDs, and let's see what IDs we have. 38, boom. And let's go to profile. You'll see that this type is no longer the case. It's actually now restricted to profiles.iProfile. And I think it's called get profile restricted, right? So we can read the name totally fine, right? Or I think it's 38. We can read the name, but we definitely can't read the favorite number because you'll see it says member of restricted type is not accessible. So favorite number is not accessible on this type because it's restricted to the resource interface. And this concept is also applicable to structs. You can have struct interfaces and you can have contract interfaces, which we're actually going to get to later on in the week because it's a lot more complicated. But this can also be used for structs as well. So that's important to know. Now, one last thing. Sometimes when I teach this lesson, people say, "Oh, so it is possible to store private stuff on chain. I could store someone's username and password and just make it so that users can't read it by making a resource interface and restricting the type." That's not true. Although won't be able to read the type in Cadence, you actually will still be able to discover all that information directly from the blockchain. I don't know how, but you can because the blockchain is all public and open. So don't think that just because of resource interfaces you can like hide data. That is true within the blockchain, but within Cadence code, but not true in the general world. All right. So for example, one use case of interfaces, by the way, is let's say you have a function here called change name, new name string, and you say self.name equals name. Um, the reason why you would never want to return a oh the reason why you would never want to return a or allow a function that returns a full reference to the profile that's not restricted is because then in a transaction someone would be able to get a reference to a profile and call change name. So if there is a change name function, then you would want to expose a profile restricted one that doesn't allow you to call that function because obviously it's not in the interface. and then somewhere else in your contract have code that does allow the changing of the name where you want it to be, right? So uh, dealing with access control and allowing certain people to call certain functions, stuff like that. But anyways, yeah, we're gonna get much more into the use of resource interfaces when we start talking about account storage on tomorrow's workshop. So yeah. All right. Any questions about interfaces? If not, that's all we have for today. And would people want this code? Maybe that'd be helpful. Here you go. Here is the playground link. That works, right? Yeah. Cool. So if there's no questions, then yeah, that's all I have. If you want to read a lot more about what I'm teaching, I would check out chapter 3 of our beginner cadence course. This covers resources. There's a whole chapter on resources, the whole chapter on resources in dictionaries and arrays. If you want to check that out, how to add and remove them from arrays. There's a whole day on references and another whole day on resource stress slash struct interfaces. And there's also like helpful diagrams on how interfaces interact with the resource struct. So I would definitely check that out as well. And I wouldn't, if you do check out this chapter, don't worry about day 5 yet. We're gonna get to day 5 on Thursday. But yeah, in case anyone wants it, here is the chapter 3 of the beginner cadence course. So this is arguably a much better resource than watching today's video again. But yeah, you can always check that out too. Cool. So with that being said, I will see all of you tomorrow at 1 p.m. Eastern if you come back and want to learn about account storage, which is pretty cool. But yeah, have a great rest of your day, everybody, and yeah, good luck in all your building. Peace out.